Alright guys, let's continue. Welcome back to IIC Rise, and we are into the program of Python. And you guys know the motto is all about to have a complete core understanding of the programming language. Motto is to explain you the concepts, but to implement those concepts, we use Python as a programming language, right? So almost everything we are going to cover here. And guys, if you go through my last just few lecture, right, you have seen we have created a Python code, and the motto of this code is to set up networking socket for us. So it is something like this, right? If you want to create some network packet, and always the intention is, if you why you want to create the packet, because I would like to exchange the data from one computer or one mobile phone or one laptop to other laptop. If this is the case, that you want to send the data from A to B, normally we use network, and if you want to use a network, you have to send data inside one box, and this is called network packet. So guys, in my last classes, I've shown you how to create a packet using the Python code, okay, typically known as network programming. But I also explain you, if A want to send a data to B, there will be some program running at the B side, and this program should have some unique number, right? Because if A want to send the data, they can't send the data directly to the program, right? We have to use a certain number here. Let's say 1 2 3 4, and I told you guys this number is called port. And I also explain you, in the networking world, there is no use of the program name or the process name. I explain you for the A perspective. Sorry, so A perspective, if you want to send the data to B, A should know only the IP of the B and the port number. And the IP and the port number combination, guys, is known as socket. Okay, so I already explained guys this concept in very detail, and why, and all those concepts are related to socket. Okay, so technically this topic name is called socket programming. Okay, and I also explain you one more thing here. All right, if you want to send a data or want to send a packet, you have to follow you have to follow some certain rule or certain protocol, right? One of the protocols say that I am not reliable, means you send the data to B. Okay, so this packet will reach to B or it won't reach to B. There is no certainty, there is no guarantee for this. Okay, but for the A prospect, you just keep on sending data. I'm not giving you any, this is not reliable, or I can say this connection is not reliable. If B is available, there is no other issue in the network. So I will send the data to B, and whatever B want to do with this data, they can do it. Okay, so technically it's called is not reliable. So and for this there is a protocol called UDP, user datagram protocol. Okay, but the good thing is they are fast, I told you in my last class. But you think you might not be so much concerned about so much speed, right, or performance, I can say, but you are very concerned about the packet, and what you want, if A send data to B. Okay, after B receive this data, they will first acknowledge you. Then B start using this, and then only A will confirm that, hey, this packet has been received. Then the A start sending the next packet. But if B doesn't acknowledge to the A, so A will keep this data for in their memory for some time, or they again resend. Okay, something like this, right? So then we can say this connection is very reliable, and for this we have to use approach or rule or protocol called TCP. So UDP is not reliable. TCP is a reliable protocol. Okay, so we can prove this, but again, we are not in the pure IT training or networking training, but there is a lot of way we can prove that is this UDP is reliable or TCP is not reliable. Okay, but that's not so much important. The important thing about the UDP, that is a concern topic for today, that is UDP is connection-less protocol, and TCP is connection oriented. So anybody who know a little bit about networking, you guys might know or might have heard this term called connection less. So UDP come into the category of connectionless, okay, and TCP come into the category of connection oriented. Okay, and this is a very common term, guys. Everybody use connectionless and connection oriented, but what is the exact meaning of as a technical perspective, the exact meaning of connectionless and the connection oriented protocol, you will come to know in today's class. Because I believe if you really want to know the right concept of particular term and the technology, the best way is to implement, or I can say the best way is to do research or maybe the development. And that's what we are going to do today. Okay, so main topic for today is what exactly connectionless is, and obviously connectionless doesn't looks so much good. There might be some limitation on the connection length, and to improve the those limitations, right, we'll go to connection oriented, and that time I will introduce you TCP. Okay, so today's topic, guys, is TCP. All right, and I'm not going to explain you a networking concept altogether, but we require some concept to build this. But today's main topic is how we can do socket programming using Python for the TCP protocol. How to do UDP programming we have already seen in my last classes, but today my plan is for TCP. Okay, but before this, let first understand a little bit more about the UDP. And idea pretty simple. If you want to use TCP, there might be some reason, right? If UDP will do everything for us, or is doing everything for us, so there is no need of TCP. But there might be some limitation on the UDP. First, try to understand those challenges or those limitations of the UDP, and then we move to TCP. So I think my agenda is very clear for today. Today we are going to do TCP programming, okay, using Python. Okay, but again, I want to summarize. If you want to send a data from one computer to other computer, right, either your data will go via connectionless or they will go via connection oriented. Okay, and UDP is just one of the example of connectionless, and TCP is just one of the example of connection oriented. There's other lots of protocol available in the market who will give you connectionless and the connection oriented capabilities. But what is connectionless and connection oriented? Let me explain you in detail. Okay, so guys, if you guys go through my last classes where I explain you how to do a UDP programming, I have given you one task. Okay, and task was to create a chat program. And guys, if you really try to build a chat program, okay, using a UDP protocol, I believe you might stuck somewhere. Okay, or maybe your code become a little bit very complex. Okay, what I mean by this, for example, A is one of the laptop, B is one of the laptop, and A and B want to chat. Okay, and idea pretty simple. If A want to send something to B, so A will create a packet. Packet will go to B, and in the B there will be some program who has a capability to receive this packet. So we can say this is a receive program. Okay, receive program, and B will receive it. Again, and after receive, B will print this data because this is a chat program. And obviously in the chat program, if B want to see what A is sending, so after receive the data from the packet, they will print those data. And how to print a UDP protocol we have already discussed. So A is sending this data using a protocol called UDP. Okay, but in this case, B program should have some port number, let's say 1, 2, 3, 4. Okay, so A is sending the data to IPB. Let's say IP of B is 2, IP of A is 1. So A is sending data to IP2 on this port number, and B will receive. Okay, but in this example, guys, if you run a receive program at the B, so in this case only A is capable enough to send the data only, and B can only receive the data. Only receive the data. Okay, but if you want, B can also send the data to A, because this chat program, chat way is two-way, right? If A is keep on sending data to B, is called one way, but chat is normally not a one way. Okay, so if you want, B will also send a data to A, so we have to get same receive program. Okay, a receive program or receiver program at the side of A. and because this is at the side of A, so A will decide what port number they want to give this program. Let's say they decide to give a port number 22222, and then A will tell to B that I am sending data to you or chat message to you. Okay, but if you want send some information to you or chat any message back to me, okay, chat message back to me. Okay, so I'm just providing you my IP address, my port number of this program. Okay, and what I want you B will use some program here. It's called sender program. The way I use, A also use here sender program to send the data. So you send a program, and in the sender program, just type my IP address, type my port number in the sender program, okay, and send a digital. And obviously, if you do so, my receive program will receive it, and my receive program will print it. So finally, it look like chat program. So A is keep on sending the data to B in the port number 1234. B is sending data to A on the port number 2222. But in this case, guys, you know what challenges we have? Okay, finally, the task I have given to you, maybe some of the guys have tried this and it is working good. There is no challenge, right? But if you talk about challenge in the terms of management, there are a lot of challenges we have in this approach in the management perspective. The one challenge is, right, we are limiting B that only send a reply message to A. Because if A send a data to B, okay, B has to first open this program written by some of the developer, update the IP of A, one, update the port number of 222, then send the data. But before they do so, right, or before they update this program by some of their developers, okay, in fact, technically, guys, it is not good practice, to every time ask your developer to change the code before you reply. So it is something like this. If I'm chatting to you and if you want to reply to me, you ask the WhatsApp developer and say, please, can you change the IP address and the port number of the sender? And here the sender is Vimal. So it is not good practice, right? First of all, or not practically possible also. Second thing is how B come to know the IP of A and how B come to know port number of A. Somewhere they have to find, in last class I've explained some function available through which we can find the sender initial if A send data to B. So somewhere we can find the IP and the port number. Okay, but it look like very much complex in the terms of management. First B will find the IP of A, then the port number of A, manually use this IP and port number write in the program, or maybe we can write some program that will automate do the thing for us. But it look like very complex. Okay, but in this example, guys, there is one big issue. Maybe somehow you write a program where you automatically find IP and the port number of A when A send initial data to B, okay, as an initial hi message, for example. So somehow we can solve this issue of management, manually update the program by some automatic way. Okay, but the biggest challenge you will achieve here is, right, here is, let's say we have one more computer, like computer C having IP3. They also have some sender program. They also have some receiver program. Okay, and at the same point, okay, A is chatting to B, and the same point C is also chatting to B. Right? It's possible. Okay, so C is also chatting to B. Okay, now point is, obviously it is but obvious. Sorry, it is but obvious. If B is receiving any data, so they use only one program, one software, one process, one app. It is not like this. For A they use a different program, and for C they use different program. Or it's not like this. For A they launch a different port, and for C they launch a different port. One program, one app, one process, one port number they want to use for receive. Okay, but if means if B use one single port number, one single program to chat with A and chat with C. The challenge is if A is sending data to B, C is sending a data and packet to B. Now B want to reply. Okay, when they reply this packet, this packet, where they go. Obviously, in the program they have to update. But if you see here, guys, again for standard program, either we will have two different programs, or they or in both the program they will manually go and type the IP 1 and 222, type the IP 3 and what are the port number they have, for example 333, update that. Or maybe there's A send a data to B, B will again reply, then B is waiting for getting the data from the A. Okay, but maybe there's same time C will send data and they will reply here. So technically, technically, you if you really have done the my last class Udemy program, and if you really write the chat program and try to chat between 2 or 3 computers and 4 computers, you will see there a lot of mess is going on. Okay, very harder to separate this guy. Okay, very harder to manage the code also. Okay, and if you think is a bigger world, it become more complex. So technically, if you do and exchange the data between 2 computers using a UDP protocol, right, you will always see this kind of big mess. Why? Okay, and what exactly, when I show the demo also I will again show you. But what is the challenge here again in the UDP work with the concept of a concept called where UDP say if you have A computer, you have B, and if you have C, and if A sends something to B, okay, everybody forgot. The somebody come from IP1 and send something to IP2 in some of the program. If the program is working on the UDP, so A forgot that we have connected to B before, or or B forgot that somebody has connected me long back or maybe some time back from the A. They forgot, right? It is exactly you can think, if you want to understand this concept, you can think it is something like this. From your mobile phone A, this is a mobile phone B, and A will do a text message. I'm talking about pure text SMS. Okay, so if A send a text to B, again first of all, SMS, there is no giving the guarantee they will they will send the message, and they will have 100% reliability, or whatever. Whenever you send the message, same point in time they will they will receive it, or maybe they might not receive. Okay, as such we don't have a proper acknowledgement for the text message. Okay, so you can think it's just a analogy, just an example. You can think text message concept is like a UDP concept. is connectionless, no guarantee, no reliability. Okay, when you send it, okay, you send it whenever they have a time. There is no network issue, other issues they will receive, otherwise there is no guarantee. Okay, but guys, if you think, if you A think they want to send something to B, and very much sensitive information, very much critical information, so normally you don't do text send the message. Normally what you do, you always call, phone calls, because phone call is always reliable. Because when you call, this guy will receive. Okay, and when they receive, there's one connection between A and B established. This is a connection created, or we can also say one session created between A and B. And A will say B hello, and B say hi. So we know to whom we are talking to, right? And after the session established or connection created, then we start sharing the information, what message A want to convey to B. Okay, but this time, just think in this way, this time, okay, A is the one who called to B. Okay, but in same time A will send the data, but in the same session, in the same call, B can also reply without dialing the number of A. Or maybe most of the time without knowing the IP of A or mobile number of A. For example, you're dialing from in the landline number. Normally in the landline, maybe you don't get the mobile number also. Right? So without B dial to A and connect back, okay, B can also send their data and send the information and talk to A. Okay, so you can think phone call or landline call will first help you connect between two systems, between two calls. This called connection establish, so that both the side, maybe one guy connect. Okay, one while will send, this guy is receiver or sender or the caller. One guy connect, but both can talk to each other. Okay, so you can say, if you do a phone call, it is very much reliable. Because obviously when I talk to you, you always say ha, yes, no, something like this, right? You always say something in reply, so that is called acknowledgement. So if I talk to you, you always acknowledge, so I am pretty sure from A side that you as a B receive my information or my message. Okay, and B can also send talk back to me. Okay, so phone call, you can think, is a reliable way. But for this reliability, what we have to do, we have to first connect to each other. First we have to connect both the guys, create a session. Okay, so phone call, guys, is just a concept. Okay, as again analogy. Okay, but you can compare phone call as a TCP. TCP, guys, again behind the scene do the same thing. Okay, first between A and B, first we connect, we establish the session. Anybody who by chance know TCP, we are not, this is not pure networking class, but anybody who know by chance TCP, so in the TCP is called three-way handshaking. So when A want to connect to B using a TCP protocol, they do three-way handshaking. It is something like hi, hello. When somebody receive the call, we always say hi and hello. So something like this, they do behind the scene. Okay, and let's say that means connection established. Now A want to talk to B and B also want to talk to A in the same session. You can do it. Okay, and that is a reason TCP known as connection oriented. First we connect the thing, then we start talking to each other, or we start sending a packet to each other. If you talk about the computer perspective. Okay, but in the UDP, something like SMS, first of all, guys, do not work on UDP. It's just as example perspective. So SMS, you send the message. Now it is your choice of B. The phone might be switched off, but you can send the message. Then there is no error come up. Same kind of demo I show you in my UDP class in last class, right? Okay, so you say I don't have to first establish the connection. I don't have to say hi and hello. I just type message and text send it. That's all. If they are available, they receive. There is not an issue. They won't receive. Whatever the case would be, but I don't have to establish a connection. So that is the reason, guys, UDP is a connection-less protocol. Okay, and that is a challenge you will face here, because A and B is not establish any connection, and C and B is not establish any connection. So if you create that program with UDP, okay, if A send data to B, that's all connection. There is no connection. Same time C can also send the B. So if A is chatting to A and C, there's a lot of mess happen. You create two separate program for every guys. So so guys, I'm not creating the program for the UDP right now, but if you really done my task I given to you, you guys might see this kind of challenges there. Okay, or maybe you create one receive program. Okay, and I told you guys in last class, use multi-threading if you want multiple guys send a data to you. Okay, so that if you get two thread for receive. Okay, and if you really do so, guys, and it's a good practice to do, right? You know what happened, guys? A is sending something to B, they're communicating, but suddenly if C send the same session in the same chat message, you will see C message also come up, because technically there is no connection is happening. They don't know, but nobody know each other. Whatever they are getting on that particular session, on I can say that particular connection or that particular port, they receive from all the guys. So I think if you really do so, done my task, you might get the idea what I'm talking about. But don't worry, and today when I go for TC programming, you will get you come to know how beautiful just to way this protocol has been designed. Okay. So guys, I believe very high level idea got it. So UDP is great but in the terms of speed, but if you talk about to maintaining the session and to talk about that B should maintain that somebody's A is there who is sender, who is keep on sending to me. Okay, so if I want to also send back, so we will use this session to send back something like this. Okay, so what is our today's plan? Today's plan, guys, we are going for TC programming. What is our intention is? One of the intention is if A want to send a data to B, okay, B, first of all, B, we have to create a receiver program. Maybe sometime you can also use say the word called server program. Okay, or let's say on port number 1234. Okay, and here B is only creating the receiver program. There is no sender program in the B. And here A is only creating the sender program, or maybe sometimes called client program. There is no receiver program here. Okay, but if A connect to B, okay, because they are using TCP, so internally they first create a connection. Connection, guys, technically known as session. After the create a session, so this was one some second of connection break, I think, from the internet, but I stopped that point in time, so you miss and you didn't miss anything. Okay, so in this case, B say I am a server program or the receiver program. A say I am a client program or a sender program. Okay, and when A connect to B, B say, and now, guys, this time we don't have to update my program in the B, and we don't have to create any sender program in the B side to send something to A, and create one receiver program in the A. We don't have to do anything like we have to do in UDP, and this is the way I ask you to do in the UDP. Okay, now because this receiver program is because working with the TCP protocol, and TCP protocol maintain a connection or the session means technically internally B say, okay, whenever anybody come to me, I don't know, it's maybe A, C, D, whatever IP they come on. Obviously they use some kind of client program or a sender program. Okay, I will create a independent connection for everyone. I will create independent session for everyone. Okay, means in internally I will maintain somebody from C, from IP let's say 3, and the client program number let's say sender 2, okay, is come to me to send this. So if I want to reply to C, so I will use only this pipe, this connection or this session to send something to C back. But for this I don't have to update my code. I don't have to update the program name or the or the IP address of the centers, because there might be millions of centers. Guys, you can think this is the same concept everybody using. For example, this B is not a B. You can think is a Google server. A Google server. Maybe Google server is also a web server. Web server is also work like a receiver or a server. And your computer is work as a client or sender, like let's say Chrome. Okay, so right now, if I go to Google, so I connected, I am a client program, a Chrome. Okay, so I am a client program or a sender program. And somebody has created a Google server or Google web server, or whoever guys created this somebody has developed this, and what they have developed a TCP code or TCP program, and they're working on some port number, 80 port or 443 port number, they're working there. Okay, but there is no sender program they have created, or Google never know initially your IP address. But as soon as you connect and start typing, for example, I'm searching for Linux, okay, the output come up. And right now, guys, this same point in time, maybe millions of guys connect to Google, same server, same name, same IP address. Okay, and Google reply to everyone. And why they can reply to everyone in parallel? Because of multi-threading. That's a different point. But point is, my reply, whatever I send Linux, right? So whatever I put output Linux, they send to me only. They doesn't send to other guys. Okay, how? Because this is my laptop, let's say IP1 Vimal laptop. So as soon as I connect to Google maintain a separate connection session for me. You can think one pipe they created for me, and say whatever I want to send as a reply back, maybe chat message, my output of my searching or XYZ chat or other things, chat message, maybe I will use the same pipe to send to it. Even though initially I don't know any IP of this guy, but when this guy connect, internally I maintain some information about this guy and the program. The program here, program here, what is a Firefox program or Chrome program. And that is the reason, that is the reason, right? In the networking world, there is no program name send, right? And that is the reason, guys. Sender program also have port number. This is called client port number. Okay, so whenever you whenever you open a tab and connect to Facebook or Google, this tab have their own this tab, not complete Firefox. This particular tab will work as a client, work as sender, and right as soon as I hit enter, okay, and if you run the netstart command in your command terminal, you will see this tab. That point in time will have one new port number. There's a random port number, but that's okay because when A can connect to B, it will send, means my laptop will send my public IP or my IP address and my this point in time my tab port number to Google. Okay, and Google will maintain this thing somewhere in the memory. That's called state. They maintain the state, or I can say connection session somewhere, so that whatever they want to reply, they can reply on the same IP in the port number. Okay. So as such, guys, this information is not so much important for you, but I'm just trying to show you all the internal concept of what is happening behind the scene. But technically, in the simple line, we always use a term called session and the connection. Okay. So and guys, this concept is only only available. No, sorry, not is like only, but this concept is known as connection oriented. And if you want to implement connection oriented, then we have to use TCP protocol. TCP, one of the famous example, where we can control the transmission. This is called transmission control protocol of our packets. Okay. At the same time, C can also send the data, D can also send the data. So this receiver program will maintain all the guys' state, all the sessions, right? So they can communicate to each other. Okay. So when I do this programming, you will come to know what is happening. Okay. So let's directly jump to the guys' code. That makes more sense, right? So TCP is a connection oriented. What is the meaning of connection oriented? I wanted to explain you. Okay, very high level. I think you guys got the idea. Okay. Plus, when you go for the practical, you will get a proper idea. Okay. So what exactly we are going to do, right? Similar kind of code what we did in the UDP, but in this computer, let me write here. So one computer, in my case, I'm going to use Linux operating system to work as a receiver program. Okay, and this receiver program we are going to build using TCP. Okay, so this is one of my Linux system. I'm going to create one workspace. Let's say workspace 20. 21. And I am going to create, let's say, receiver.py. Okay, this is my receiver program. And either you can use as TCP or UDP. Your program will have some port number. And you tell your program that what is your current system IP address. So it means you have to use IP and the port number combination. Okay, and if you combined IP and port combination is called socket. So technically you have to do socket programming. Okay, and how to do the same way, import socket. Okay, and in the socket module we have a socket function available, the way we use in UDP. Okay. And now because our plan today is to use IPv4, so I can say socket, I am going to use your address family called INET, means IPv4. And socket, if you want to use UDP, then you can use dgram, the way we use in the last class. But I want to create a socket that will send the data, not with the UDP. I want to send data using TCP. So here, guys, the name of their socket is called socket streaming. Because TCP is, it creates a session for you. A session is something like streaming. So you can send the data, B send, A send, B send. They keep on sending data to each other. So it is like this. It is like a stream we are going to create. Okay. So guys, tell me. So guys, this is the only thing you have to change here. And now you tell your IP address, your current computer, and you tell which port number you want to run this program. Let's say 1234. And I told you guys in my last class what a port number you use, because I'm using this port number for TCP. So you can use netset have an TNLP command. Okay, here T stands for TCP. Just check the port number 123 is free or not. This is free in my case. And also check your IP address. So in my case, the IP address is 129. Okay. So I'm writing here the IP of my own computer is 129, and the port number that I'm going to use is this one. So if you want to use this IP and this port number, you have to create a socket like IP comma port. But in this IP and port socket, you have to bind with your own program. So for this, you have to use s.bind function. Right. So this till here, guys, your code is exactly the same. Okay. Let's see. Let's run a code till here. Let's see what happened. Okay. So when I run my code, nothing will happen. Okay, because we are not doing anything. Neither we are receiving, neither we are sending, right? But let's do one thing. just hold this this code for some second with input function. Why I'm doing this? Because I would like to hold my program till here. Why I'm holding? Just to confirm when I run this code. Okay, does system bind my program r.py program process with this port number and the IP address? Okay, let's see. So what I'm doing again, I'm again running my code. My code is still running. Why? Because I use input function. This input function hold my program for some time. Okay, and now again I'm going and check my netset command, and what you notice here, guys, is still still my program is running. Even though if you run the ps command, you know this command, and search for a program called r.py. Guys, this program is running right now. This process is running, but you don't see any port number 1, 2, 3, 4. Okay, why? Because this is a TCP programming. And in the TCP programming, guys, if you want that anybody who come to B, okay, and B will allow them to connect. And after connect, okay, B will maintain the state. Okay, so we have to start this program in a state called listening mode. Even though if you see here, okay, there's some other program running. For example, this program called SSHD running. Or for example, HTTP web server running, you guys know, on port number 80. But somebody has written TC programming, and they run this program or process with this port number in the listening mode, listening state. Because, guys, state or the information is only maintained by TCP. If you go to UDP, if you search for UDP, you won't see any information concept called state here. There is no state. Okay, so in the TCP, we have to start your program with listening state. Then only they will remember the connection in the session. It is something like this. If you want, if A do a phone call to B, okay, and B will capable enough to receive the call, and that point in time the call is going on, B will have a continuous connectivity with A. So you have to maintain the listening mode. You can think in this way. Okay, so how to do this? So in my programming code, you have to write here. Okay, what in this same socket, I want to start my program in some listening mode. That's all. That's the only thing you have to do. Okay, and it is compulsory. You can think in the TCP programming, you have to do this. Okay. Now let me run my program. Okay. And this program is still running because I use input function here. But what difference you will see now in this program? Again, same process start. But this time what you will see, this process having process ID 3504. Okay, this process you can see here 3504. And now this time this process is running with the port number 1234. And because we are into the listening mode. Or because we are into listening mode, it means any of the sender or the client, they will have a TCP three-way handshake. Okay, they can do with me. It means they can at least connect the call, or they can actually create the session. Okay, that's the meaning of this. Okay, so let me close this program. So in the TCP, guys, we have to write a listening. That's my main point. Okay, so till here, let's say a program is complete. Let's say program is completed. Okay, now what I'm doing here to test this program, let me run this program again. The program is running. To test this program, what I'm doing here, I'm going to create a sender program. So in my example, guys, what I'm doing here, I'll take one of my other computer, that's my Windows, and I'm making Windows as a client or as a sender system. Okay, so let's use Windows. So I'm going to create a new program here. Again, a TCP programming socket, and S. And guys, if you don't write anything in the square bracket, let me write here. I don't want you guys to be confused. Again, I'm going to use IP4, and because the receiver side we are using TCP, so here we also use TCP. Okay, so that part is done. Now I am a sender program, and guys, it's but obvious if you want to send something, you have to send a data to the where you want to send the data. But guys, if you remember in my UDP program, okay, what I did from my sender, I directly send the data without connect. I just use a sender to function. If you remember, I directly send the data to this guy, and at that time, guys, I show you in some example my system was shut down. In some example, my IP port number wrong, even though there's no error come in the Windows side, no error come up. Okay, because that was UDP never do the connectivity, and because they never do the connectivity, so the receiver system or server system are alive or not, they are exist or not, they are not so much concerned because they are non-reliable. But here in the TCP, before you send the data, you have to first connect it. You have to first create a session. Means it is something like you have to first do a phone call first, let the receiver guy receive the call, then you start talking, something like this. And that is the reason, guys, in the TCP, in my sender side, there's a function called connect function. Okay, and in the connect, we have to provide the IP address and the port number. Okay, and let me use the IP address here. Let's say IP address 192.168.0.129. And let's say port number we know of receiver is 1234. Okay, so I'm connecting to this IP and this port number, and this is the actual IP of my receiver program and the port number. Okay, but if I give the wrong IP here, let's say 12, and this IP, guys, is right not exist here. You can see it is still waiting. But if you see in the UDP, they never wait. They will send the data. But here they're still trying. After a certain time, they won't find IP12, and they give you some error. Because TCP, guys, never work without the connection. Okay, and you see, guys, connection attempt fail. Connected party does not possibly respond. We don't able to establish the connection, something like this. Means they have to first establish the connection or the session, then they start sending the data. Okay, it is something like this. Okay. um, uh, so so let me use IP129 that is actually exist. Like there is no error come up because one IP129 exists and this port number exists. So technically they connected to this my port. So you can think, guys, the connection has been established. I'm going to guys show you one more guys command, right? Very interesting command in the Linux. If you see the ongoing connection is going on, you can use this option. Net should happen NCT. Okay, this is a very interesting option command available in Linux. Let me share this command to you. If you want to see the ongoing connection, you can use this command also. For example, if you want to see Facebook connected, your browser connected to Facebook, or browser connected to Google, so the live connection that is going on, you can use this command to monitor the live connection. Okay, and what you see here, by chance, you can see somebody foreign, but from outside computer, has established a connection, right, to one of my IP address and do this port number using TCP protocol. Okay, somebody has established this connection. Okay, and from where? 141. Okay, so technically, if you look at this screen, okay, it is but obvious. I know this IP is my Linux IP. This is my Linux port number where I am running the receiver program or server program. And this foreign IP system, obviously this IP of my Windows. Very quickly, if I check if or IP config command in the Windows terminal, 141 is my Windows IP. And but of us guys, there's a port number here. I told you guys, whenever senders send any data, okay, they always use a port number. Okay, without the port number, none of the program will start, neither client or server. But this is a random port. Next time, maybe port may be different. But that's okay, because when the sender send the data to receiver, or when they connect first time, okay, a sender will send all the information to the receiver. So if the receiver want to reply, they can reply on this IP in this port number. This is a random port number used by a client. But this is not so much important here. Okay, but I just want to tell you, okay, if you want to see the live connection going on from your computer to any of the remote computers, you can use this command. Okay, so you can see connection is going on. Okay, but if you want to disconnect, let me see on the real time. Okay, so just go to Windows again, and you can use an option called s.close function. So I'm asking guys, to whom your guys connected, just disconnect from this guy. Okay, if you see here, close wait. See here. So last time it was established. Now sender send the request that I would like to close the connection. So you can think this connect is like calling somebody to this IP mobile number, and somebody receive. Okay, somebody received. So this from calling to receive is a part of the connect function. And close means you are the one who call, who you, as soon they receive, you disconnect. That's all. But the actual game is between this. After somebody receive your call and you disconnect, we have to do a transaction of a chat or your message or your information or your data. Okay, that's what we have to do here. Okay, and so what I'm doing here, but I want to show you that it was working great. There's no challenge. And so let me stop my program and again rerun. Now what actually we want? We want, okay, after Windows connect to Linux, okay, okay, this Linux system would have a capability to receive something. And Windows will have a capability to send something. Okay, but at the same time, Linux also have a capability to send something, and this guy also have a capability to receive something. Okay, so if you guys remember in the UDP protocol, if you want to send something, the function is called send to, or if you want to receive something, the function is called receive from. But in the TCP world, if you want to send something, the function name is send, and if you want to receive something, then function name is called receive. This is the function. Okay, but the good thing is, as soon as you Windows guys connect to this receiver program, right, then both the side can use send or receive. So your receiver can also send, they can also receive. Windows also can send, also they can receive. Okay, both the things can do in parallel. Okay, but before this, there's one more thing we have to do here. Okay, that is, I told you guys, whenever in the TCP, one minute, TCP world, whenever A, C or D want to connect to receive program, they will maintain the state, or I can say they remember you, that this particular connection is for A, this particular connection is for C. Or at the same time, we can create all the session connections. Obviously, you have to do some multi-threading here, but technically, B should have a capability to remember the session for the A, so they can use this session connection to, or you can use this phone call, current ongoing phone call sessions to send and receive. Okay, for this, in the B side, we have to write one more code. Okay, the code is, one minute. Okay, even though guys, if you run the input function and remove the input function here, close the function code and run the code, you can see nothing has happened. Okay, even though I have written the listen code here, okay, but listen code say there is no meaning to start this program, bind this program, and start listening on this port number, because this program don't have a capability to maintain the connection or the session for the client. Okay, for this we have to use a function called accept function. Okay, what is meaning of accept function is, I told you, when A connect to B, B say, hey A, I know you, now I will remember you, I will create one session for you, we can keep on talking to each other using this phone call or this session. Okay, if you want this, okay, so B should have to accept the connection for the A. So there's a function called accept function we have to use here. Okay, and this accept function will give you some output. Let me use O variable as the output, and just want to test, you can use O or maybe let's say X to test. Okay, so what will come up, let's see. Now I use accept function. Now guys, this time I'm not using input function to hold my program. Okay, because now what you see guys, this program is waiting for you. Why they wait for you? Because we use accept function. Accept function say, I keep on waiting till one of my client or sender connect to me. After the connect, I will maintain the session for that guy. Okay, something like this. But if you see here, your port number started the same way. Okay, but there is no ongoing connection for one of my client. But if I run this code again, this part, you connect. Okay, there's some operation attempt, because I think we have to again start the program. Connect. Okay, and if you notice, somebody has connected, and now guys, this time you can see finwheat. What the meaning of this? Anybody who know by chance networking, there's a multiple flag in TCP. One is the fin flag. I don't want to discuss right now, but if you see here, this program automatic close, and what you found, this output. And you know the meaning of this output, let me explain you. Okay, the meaning of this output is, okay, your receiver program say that somebody from the sender connect me or because I am using accepting function, so I accept that connection, and I create one session or connection for that guy. Okay, and name of that connection is this one. So there's one kind of, actually you can think is one kind of reference variable they create, or one variable they create on the RAM. So they say I create one variable in the RAM, at that variable maintaining the information about my sender. And by chance also know one more thing, the remote address of my sender. So this is the IP of my Windows, and this is the port number they have. So technically, from here till here, this entire box is the information about about whatever the highlighter, right? Okay, this is the information about uh, the sender. Okay, and this information, guys, is very important. You can think, if I create this diagram again, guys, in this example, the accept function give you two information, one from here till here. If you see this bracket close here and this start here, this is one information, and this information is called session information or connection information. So who connected to me? This guy. From which program port number? This one. What we have to do? We have to maintain the TCP information. So in the future, we can use same session, same connection to do sending and receiving in one go. Okay. And after there is a comma here, if you see, and there is some other information. Okay. So technically, what I'm talking about, there's one tuple here, and this tuple we have a 0 index and 1 index. What I'm talking about, they may write in the code. So when you use accept function, guys, they give you two output. let me store one output in a C variable and one AD variable. Two output they send. Okay, because they are sending two output, so I store one output in C variable. C means connection. Connection means where I'm maintaining the session of that particular sender and connection of that particular sender. And this C information from here till this bracket, till here, this whole line. Okay. C is very important thing for us. And address is just like, if you guys remember in my UDP also, in my receive program, we also received the address of my Windows system. Okay, so this address might not be so much important here. Okay, now the good thing about the C is, C say, okay, now if any of the, let me write here, if any sender connect, I memorize that guy, or I can say I maintain the connection. Okay, maintain the connection, something like this. Means I know that guy, and how I know? I store the information of that guy in a C variable, or I maintain the session in the C variable. Now you can use this C variable, right, to send the information, C variable to receive the information. Both the thing you can do. You don't have to go to your client or to your sender to again start the receive program there. Okay, just one single connection I can use, send multiple time because it's a chat message, right? In the chatting we can do send hundreds of time, or we can receive hundreds of time. So in one connection, I can keep on sending, I can keep on receiving, keep on doing it. And after a thing, now you want to disconnect or close the session, you just ask the C and say just please close it. We can use the close function to disconnect. That's a different point. Okay, but guys, this thing you can't do in the UDP. If you just try to think, anybody who ever try UDP, very complex or very hard, or maybe not possible, maybe. But here, just by creating one connection, right, in the same connection, we keep on sending, we keep on receiving. That is the reason, guys, TCP is known as streaming or connection oriented protocol. Right. So let me show you one demo. So what I'm doing here, let me only receive it. Okay, only receive this. Okay, so what happened? This program is working on TCP. The name of this program is called bind socket. This one, they come on the listening mode. Then only we can enable the port. And this was a very important line. This program say, okay, any of the first client who connect to me, I will accept the connection, store the information here. And one more thing, guys, only one client can connect at one point in time. But if you want multiple guys to connect, you can put this code into the multi-threading. So create a multi-thread here. And my program is only receive the thing. Okay. But at the same time, they also send the thing. Okay, send the thing. And let's say they want to send something. Let's say hi from server. And obviously, guys, you have to use byte type. Byte data. I told you in my last class. And again, when you receive something, you have to give some kind of buffer size. Okay, and let me store this guy into X, and just for testing, I'm just printing X. Okay, so what happened when I run this code? Let me run the code here. There's no error come up, but what actually they're waiting for? They're waiting for the accept. Okay, and after accept, they will also wait for the receive. After we receive the data from this customer or the client, they will print, and then they send this. First they receive, then they send to the same client. Even though, guys, in this code, I haven't tell anything about my client because I don't know the IP of the client. I don't know the port number of the client. I don't know. But on the fly, they will receive that information and give me the opportunity to send to the same data. What are the client date point in time? Okay, so so if you see here, they're waiting, and now when I go to my Windows, again run my code again, run and run. There's no error come up, but they're still waiting, guys. Okay, it means if I open my terminal, new terminal in my Linux, and run nct command, you can see now session established. Okay, from my Windows. Okay, and why they established? Because my program waiting. Why? For what? For receive. But when they receive, okay, when Windows send. Now Windows want to send, again they say send this data. You use send function. Okay, so whatever socket you have connected, you just send it. Or let's say you have to send hi, I am client. And obviously, guys, you have to use byte data type. Okay, no error come up, and what I'm expecting, this data reach here. Okay, reach here. Okay, but but in my code I also use send. So as soon as this, because output come 2 times, because I use print x 2 times, so there's a reason, guys, I was surprised why they print 2 times. So what do you see here? Let me remove this guy. Okay, so what do you see? This guy receive, address receive, print it, and this program will send. So from my side I have sent, but there will be somebody from Windows who should receive. Okay, so because they are sending there, so again you have to use some receive function here also to receive. Guys, here we receive it. Even the very interesting thing, if you see, even the program close. Okay, even though I can able to receive the data. So guys, this concept is not from Python actually. Anybody who know a little bit about networking in detail, so there's a concept of networking buffer. Okay, so there's a lot of TCP buffer we have. So maybe server send data to me. Okay, or let's say your Google send data to your browser, and your browser may be busy somewhere. So in laptop buffer, they store some information, and whenever your browser free for some operation, they will get data and print it for you. So there's a concept of buffering. So I don't want to go for. So anybody who whenever go for networking performance, they're very advanced topic we discussed there. But it's very interesting concept. Even though my server program stop, after some second, I'll use a receive program and I can receive the data from the server. Okay. But one more guys, can you hold for a second, please? Okay. So technically, if you notice here, okay, I connect only once. Connect means we have established a session and the connection. On the same pipe, on the same connection, I can keep on sending, I can keep on receiving, but obviously the context will be something like this. If you send, that guy in the same time receive. And if this guy send, then your side you will receive. Okay. But guys, in the chatting world, it's not work like this. If you are sending, this guy is waiting, and till the time you send, this guy won't able to send to you. So guys, here this is again one of the great example where I want receive and send will work in the same time. But I don't know that guy will send 100 times, or maybe won't. But I want to send something. Okay, so there's a receive is a different function, send is a different function. I want both the function work in parallel. So again, guys, here the role of multi-threading come in play. So what is multi-threading? We already discussed in almost in detail. So I want, if you really want to create a chat program where both the side can send and receive to each other with any point in time, anybody can send, anybody can receive, then put both the program in the multi-threading. This is one thing. Okay, but in this guy's code, we have one limitation. One limitation in this code is right, we have only one except function. Okay, it means this program will only run for one single client and one single sender. But if you want, hundreds and thousands of sender will send and connect to this program. Okay, we can think this program is like Google search program. Okay, so it's a Google search program, and Google server guys may be connected by thousands of guys. Okay, and all the 1,000 guys connect in parallel. So again, guys, here you have to use multi-threading in some loop, in some while infinite loop. Okay, so I'm just giving this two tasks to you. I want you guys to convert this program into a proper chat program. A chat program that anybody can receive, anybody can send at any point in time. So this is my receiver program, or this is my sender program, or sender program, receiver program, whatever you say in the chat perspective. Okay, you can use. Okay, but guys, today my whole info of I would like to take one more class on this, because in the next class, today this is just a receiver and sender program. But if you do some small trick here, the same program can be converted into a server and the client. Okay, and if you optimize this program with some kind of multi-threading, this become a very huge program, right? For like a real world prospective program. Okay, and lots of things we can achieve there. So anybody who know web server, anybody who know mail server, SSS server, telnet server, you can also create by yourself. Because HTTP server, SSS server, telnet server, they purely work on TCP. Okay, their client also they connect. Okay, and the server first accept the connection. And behind the scene, they have some receive and send. They keep on sending and keep on receiving. Okay. So today's guys' plan was to give you the idea of what is limitation we have in the UDP. It's not about UDP is bad, but that by design they have connection less. But by design, TCP is connection oriented. What I mean by this is the actual line of TCP. TCP say I will first accept the information from the client. I will remember the connection on the C variable here, and now for this point for this client, what I want to send and receive, use C variable. For other client, we can use C1 variable. Other client, we can use C2 variable, C3 variable, or maybe here we can go for object oriented. So in my upcoming class, again, when I start object oriented programming, that become more simpler in the terms of management. That's the different point, but I want please convert this code by implementing a multi-threading into a chat program. Okay, at least I want you to try this. So I think a lot of guys command I've given to you. None of the Python coding networking. Maybe you can see this kind of function a lot, but the way I explain you by some commands and show you real time, nobody normally show you this kind of demonstration. But it's very important to see what exactly happening behind the scene. Okay, so that's all, guys, for today. For today, I'm opening the chat box. Any queries if you have? Okay, you can ask me, guys. Very important topic. If you practice this one or two more time, lots of real practical products, software, servers you can build by yourself. Okay, she'll share the code in your Google Doc of client and the server, or I can say receiver and the sender. Just try this. Any queries if you have, you guys can ask me. Your chat box is open. You can refresh the page, go back if the chat box is not come up of YouTube. Yes, Ram, we will soon start Flask. Don't worry. Okay. For this, I have to. I'm capturing and providing multiple information, because when I start Flask, you should know something networking, API, web, maybe ops. So I'm collecting multiple information here, providing to you. So when I start the Flask, conceptually you will be have a complete idea of the programming. Yes, there's no as such difference between normal OS and Cisco iOS. Cisco iOS is also one of the customized version of Linux only. Okay, so I worked a lot in Cisco iOS, all right, that operating system that you use in the Cisco router. So it's a thin thin version of the Linux OS. They have their own program and pre-created commands. Okay, so that's the only difference. But normal PCs, they don't give you protocols like OSPF or EIGRP, but they give that program. That's the different point. So yes, Unsik, you can use socket.io to build a chat program, but intention here, Unsik, is not to build a chat program. Chat program may be very simple task. My intention here is to give the idea, okay, how the sender receiver program work together. Okay, so I suggest don't use any other library like socket.io. Just use the same socket, so that in my next class, when I convert my code into server and client, that makes more logical sense. What difference between concurrency and parallelism? Parallelism, Akash, I have discussed. Concurrency maybe somewhere, maybe in my database class, somewhere I might use. I will explain that point in time. Please take cybersecurity course under IIC Rise. Definitely, J Kumar, I definitely try. Let me complete the Python, then we definitely try. Which protocol does chat service use? They don't use WhatsApp and Facebook. Don't use this kind of. They use TCP actually, but for real-time messaging, some protocol, or they have some customized protocol they use, right? Maybe I might try to create some application in some real-time messaging, right? We might discuss there, sort of, right? What kind of chat services and how can you build? So they have a thin down version of HTTP. If you try to capture any message of WhatsApp from some packet capture tools, you will see is a pure HTTP, but is a thin version of HTTP they use. Some can, like in IoT we use MQTT, something like this, the customized version of HTTP they use. Okay, but you can say it's a real-time messaging protocol. Okay, in the simple term. So that's all, guys, for today. I will see you guys in next.